great fixture in a lot of our meetings. I mean, you've brought her to so many meetings, and she's kind of become part of our community.
Yeah. She got a little press this morning from the USC News Bureau. I tested out an application for spherical video traveling. It's called World Traveler by this company called Penumbra, and basically she got to go back to Rome in spherical video and talk about stuff she had done 35 years ago. And it's just a great thing when you see when VR works. Right. And you see people light up, and it activates them and gets them talking. So anyway, all right.
Nice.
Back to you. Okay, so I want to hear about what got you into this game to begin with. It was before 2003. I know you worked on the Rutgers ankle, but I dug up an old paper on mental imagery improves performance and produce increased volume of activation in fMRI maps of the sensory motor cortex. That's pretty deep, but what were you thinking about VR then, or how did you get started in this this game?
Well, definitely wasn't thinking about VR. When I did my my postdoc, I was very interested in studying motor imagery. I actually did it in my PhD also. I was interested in the effect of mental activity on breathing, because, you know, like a lot of us left practice to become trained as PhDs. And it was a time where there was funding to try to promote physical therapists to become PhDs. And so I was very lucky to get funded by NIDLR to go back to school and get my PhD. And so I was trying to figure out things that we had experimented with in clinic and see if they had any, way of documenting them through research. And so during my postdoc, it was the beginning of really using fMRI to try and understand some of the plasticity from training. And so I tried to replicate Avi Carney's study, where he had done work where people had to remember a finger sequence, and then he tracked them serially over time. And we replicated that study with motor imagery. So that's probably some of the stuff that you found. And in parallel with that, we were trying to figure out if some of the ideas that have come from sports could be applied to persons with neurologic conditions. So there was some work around trying to figure out if the parietal cortex had been involved, if that somehow inhibited the ability to generate an image and use imagery as a strategy. So I did and still do have a love for the work that we did with motor imagery, and kind of took it beyond the basic science and really looked at using motor imagery for retraining walking for people with stroke. And I collaborated in that work with Ruthie Dickstein at the University of Haifa, and we did some studies in people's homes in the community, and sort of were able to show that you can actually, as a person with a stroke, imagine movement and improve your walking, which was fun. So I was, sort of happily doing my motor imagery work, and my chair, Alma Marians, pulled me in, and she said, Judy, which is the way she does things, Judy, there's this opportunity that I think you might be interested in. So it turns out that the New Jersey Commission for Science and Technology had brought together 3 very different labs in the state that were all applying for funding to do something with virtual rehabilitation. And one of those labs was Greg Berdea's lab at Rutgers. And another lab was Howard Poisner's lab at the Center for Molecular and Behavioral Neuroscience. And then a third lab was an NGIT lab. So it was like this really nice mix of people, and all of them were kind of interested in how to recover upper limb use post-stroke, which I wasn't interested in at all. So they were also looking to see if they could do some work with recovery of walking or somehow rehabilitating the lower extremity. And that's just with that little conversation, I got to meet Greg Berdea, with whom I collaborated for 9 years. And we co-developed the Rutgers ankle. And it was a really great experience because we had their engineering skill set. We had the HCI people at New Jersey, Marilyn Tremaine at New Jersey Institute of Technology. And then we had, we were the rehabilitationists. We were the clinician scientists. And so we each kind of brought something to the table to develop this system, which actually I coined the term the Rutgers Ankle Rehabilitation System. And we tried to build an interface that would make sense to clinicians. So that was really important to me. But I should back up a little, because one of the very, very first decisions we had to make was, like, Greg was really interested in robotics, right? And so he had seen in clinics that people worked on these isokinetic devices to rehab their knees. And he thought that that would be the way to interface some kind of hardware with software to build a virtual environment. And I had to persuade him that I didn't think that was a good idea, because at the time there wasn't a lot of research to show that this open chain work really worked. And I said, why don't we do the ankle? Because at some point, maybe we can actually stand people up and we can rehab walking. But the ankle really is the distal effector. That's what interfaces with the ground. And that's so critical for walking. Could we maybe look at training that instead? And he was open to it. And so that's how we began the process of developing and instrumenting this little Stewart platform.
Let me jump in real quick.
Yeah, go right ahead.
The audience.
I'm going on and on and on.
No, this is great. This is great.
It's like memory lane.
It is. The Rutgers ankle, when I saw it, I think it was in 99 or 2000. I think it was the IEEE conference that he hosted, VR conference. Right. And we had a lab tour. And when I saw it, it was like inspirational for me to see this, because what it is you put your foot on an ankle on a platform device with shock absorbers, look like the proper terms for it, but you would move your ankle forward and backward with dorsiflexion, right. And then so you can move it side to side a little bit, but you got to fly using that movement as the interface. You got to fly an airplane, right, through various targets, and the targets were strategically oriented to work your ankle the way that you would, what you would prescribe for the patient to do. And that was, I think, my first real hands-on taste with physical therapy, as and embedding games. Up to that point, I'd been working the whole cognitive area, right, and coming up with these kinds of ideas and plans. But here was one that was just intuitive, concrete, engaging, and fun. And it was like I think it is, when people write the history of VR, that will be one of the seminal applications that kicked off the birth of the field. So I just want for the audience to know the place that this thing holds, and go on.
I think it does. And I honestly do believe it's because it was so interdisciplinary. Now everybody's very concerned about being interdisciplinary, but we were so interdisciplinary. And I think it worked so well because there was all this input from people. And you're right. It was this little platform, and you sat and you put your foot on it, and then the movements of your foot would steer this virtual plane. And like you said, the motions that we tried to target were the motions that people with stroke predominantly lost. So they lost their ability to do those movements. But when we first tried it out, we didn't necessarily think about people with stroke. We actually studied people with ankle sprains, because we thought that was sort of like the natural population. And then the next thing we did is, it's not really a pragmatic trial, but we actually brought the Rutgers ankle into one of my former students' clinics. And we lived there for 2 weeks and pretty much worked with 5 or 6 different people who we thought could be, could benefit from the training. And we were there all day, and they sort of stuck us in the middle of this physical therapy clinic. And they would call us the MASH people because the sound of the plane, and people thought, we were the MASH people. And it was so fun. And listen, Skip, we used to put ice packs on the generator because this was an actuated device. And so the device needed to be cooled. And it had never been designed to run, for 8 hours continuously, which is what we were doing in the clinic. So we would, periodically have to put an ice pack on it so that the generator could put up with the temperature changes in the room. But we had these unexpected findings, meaning that this one person post-stroke had such a profound change in their walking and in their ability to do stairs with only 2 weeks of training. And we were like, we got to like figure out a little bit more about that. So that's sort of what led to iterating the device and, you know, enhancing the software. And 9 years later, a randomized controlled trial where we took the ankle because, you know, the ankle, it had what we call haptics. So in addition to reading your movement, which is very important, right? It has sensors to read your movement as you described, but it also gave you sensory information. So we had created what we call perturbations, and we, as you flew the plane, the environment would become cloudy and there'd be a storm and the platform could shake. And then if you physically contacted the targets that you described earlier, you would get bumped, you know? So we had these highly technical terms that we used to describe the physical sensation. So the platform was really nifty. And so we designed a study to see what happens when you couple the platform with a virtual environment or the platform by itself with a therapist giving you really excellent feedback. And this was, we had kind of designed everything except that control condition. And that was really part of Anat Mirelman's PhD work, where I said to her, we need to design a control condition that's so good that all we don't have is the virtual environment, but we're still giving feedback, we're still having some interactivity, but it's just, I really want us to purely isolate what the virtual environment contributes. And we found profound changes that favored the coupling of the virtual environment with the robot. And so the story was not the robot, the story was the virtual environment. And people walked better, walked farther. They changed the way they actually did their walking mechanics. So there were very clear ways we could map the results back to the training. And that was, you know, Skip, it was exciting. It was so much fun. We had so much fun doing the work. And then we would present it and clinicians would want it. And we didn't have a mechanism for them to get it.
This leads right into the next question is like, how do you go from lab-based prototype with, you know, good controlled research to kicking something out of lab and productizing it? I'm not sure, you know, I've always had a dream you could do it from academia, but there are so many barriers and funding issues. You know, what's your view about the bench to bedside issue over the last 15, 20 years of VR development, and how few of them actually have gotten out there? I mean, I think it's changing now.
I hope so. I mean, I have a lot of thoughts on it. I think one thought is just simplifying the technology. I think the interface, the hardware doesn't need to be very complicated. And clearly the way we have sensors embedded in everything now makes things easier. And I think the more organic it is with the way practices anyway, the easier it'll be to integrate. We actually, after the meeting that you hosted in Catalina, it was ICD-RAT in, I think, 2005 in Catalina.
2005, yeah.
That Jeff Lewis, who at the time was working in my lab, and I, on the ferry ride back, we mapped out the idea for the virtual reality augmented cycling kit. And we wanted to take what we had learned from the Rutgers ankle and simplify it by creating a kit that you could put on a bike. And so you would interface with the virtual environment. You would use your own bike. You didn't need a specialized bike. That was a big thing that we thought was important from a, transfer out of the lab thing. We incorporated heart rate sensing, not just motion and force sensing, but also heart rate sensing, because the problems that people post-stroke have are much more complex than just selectively moving one part of their body. They really have a big fitness requirement for walking recovery. So that project, we actually went through the SBIR route as a way of maybe seeing if it was a pathway to commercialization. And so I think that's one route. I mean, we had very good results, but we didn't get funded for the second phase of the SBIR. And Ironically, they said we didn't have enough evidence that cycling would transfer to walking, which much later was shown to be the case. So we were like, I guess, a little early in that regard.
Yep.
I don't know. So that was one avenue that we tried, doing our own route to commercialization. And we've actually tried that also through NSF and done their ICorp program, where we've taken one of our inventions. This was a different one. This was one we developed for the Connect to do assessments for physical therapy. And and we did that crazy, I don't know if you know about that ICorp program, but essentially the goal is to teach people in science to think more like people in business. And you have to get out of the building and you have to talk to your potential customers. And you're not selling them your idea. You're trying to figure out where's their pain point. Are you doing something that's going to be relevant? It's such a different way of thinking, right? And so I think that, back to your question, one of the avenues is just thinking about how we train our scientists, because I think those things really informed how we think about some of our development ideas now. But I think in the end, I think the only way to really scale it is to have a partnership with industry. And it's so tricky. It's so hard because you're trying to preserve your I'm a scientist and I'm not I don't want to be involved I don't want to build products. I don't want to sell products, but I want people to use it, right? And so it's that reconciliation between how do you scale what you do? How do you do it fast enough? It's very hard to do it as an investigator by yourself, even as a team. So I think that's where we're going. And obviously there are partnerships. You certainly are familiar with those and you're involved with them and you're sort of kind of paving the way for us to see what are the best practices for having those partnerships, right? How do you do it and maintain your integrity as a scientist?
It's really a challenge, but I agree with you. It's the only way that this stuff is going to become accessible and widely adopted is with a company that actually has sufficient funding to go through the productization process. And I've been pretty lucky that the groups that I've consulted with have a respect for the science, and they know that they're not going to just make some flashy program and put it out there if they can't point to what does the science tell us about this. I mean, this thing behind me, this virtual classroom, the same thing as what you went through. We had a version that actually got funded in 2003 by the Psychological Corporation as an assessment for ADHD or assessment for attention processes that could help inform the diagnosis.
I remember that video.
Yeah, exactly. And
that classic video of yours.
We had great data. We had, everybody loved it when they saw it and they tried it. But when we did focus groups, always at the end, the last question was, would you be willing to spend $10,000 for a special computer and a headset and software and this and that? And it's like, well, maybe my Connors will be sufficient, or my CPT that I use is going to be good enough, Tova, whatever. And so it basically, that version, which was pretty well built, became a research tool. And now what you're seeing behind me is now the sponsor of this podcast, Cognitive Leaps version, which now has that kind of productization and the resources to do what you got to do when you build these things. And that is run a lot of people through it. We just presented a 695 person normative data set from this classroom from kids age 6 to 13. And it's like, this is what you got to do.
Yeah. Nobody's going to buy scale.
Yeah. Nobody's going to buy a neuropsych test without norms.
And it takes forever for you to collect that if you're not doing it in a sponsored way. Yeah.
Right.
No, it's true. It's true. I mean, I'll share with you something we've tried that's not through industry with Roberto Lorenz at University of Valencia and Sergi Bermudez y Badia. We built this thing called the Open Rehab Initiative. And our idea was not everything is going to go through a commercialization path. Not everything will end up as a product, but a lot of time is spent through science validating and developing these simulations that maybe can be used. And we created this resource where people can go and download applications for free because there's no plan to commercialize it or no potential for commercialization, but they work. But even that, you know, trying to fund that, because they're in Europe and I'm in the US, it's not so easy to fund things globally, right? And, you know, it's a very small community. And so I think we need to figure out the funding if we're going to continue to do things on the science side that's more global, so we can have larger scale projects. Otherwise, I think it's it just becomes lots of little things that we're all sort of figuring out, and it never scales.
Right. I want to get back to this topic, but I want to kind of science nerd out really quick. Or maybe not really quick, but on
further.
Further on, you know, you were with a team that did a Cochrane database review, I believe they're called, on VR for stroke. And it's an impressive document. And can you tell us a little bit about that? And then we can talk a little bit about the state of the science and how do we do these things? Do you have to have the full-blown mega randomized control trial? Are there other ways to gather evidence and so on? So what's that process like? How did you get involved with Cochrane?
I was invited as a content expert in VR. Kate Laver from New Zealand and Maria Crotty were embarking on the process, and they really had more of the methodological expertise. They actually came to a virtual reality meeting in Israel, and that's where we met. And so I was very excited to be on board. And you know, these things are kind of onerous. You develop a search strategy, you try to define your terms, you find the articles, and then once you find them, you go through a process that's called critical appraisal, and you extract information about the quality of the articles, and then you take the data from those articles and you reanalyze it, and you come up with what's called synthesis or summary data. And so you're able to make some statements across a whole body of literature rather than one article at a time. And the Cochrane database for systematic reviews is sort of considered the gold standard for this type of scientific publication. And they have a whole internal process where they have to accept your proposal and review it, and then review your paper before it ever comes out. So that particular systematic review that you're referring to, the 2017, I think is the 3rd or 4th edition, and we are in the process of revising it again. So we happen to be in an area where the literature is constantly changing. There's so many new things, and we're already behind because we have way more papers than we thought we were going to have. So what we've looked, it's interesting because what we report in one systematic review changes when you report it again. Like the strength of the evidence to say VR works or doesn't work has changed over time, and not always in the direction of favoring VR. There's like more studies, so there's a little bit less stronger evidence in some areas. It's kind of an interesting ebb and flow to the process. But sort of the bottom line of the last one was along the lines that there was evidence of a certain kind of quality, not necessarily the highest quality, to support that using VR had benefit for rehabilitating of the upper limb and activities of daily living for people post-stroke, but not so for walking, which is sort of my area of interest. And we didn't address fitness at all, which I'm hoping maybe will come into play. But, you know, when you do these big synthesis documents, I think, you know, one of the things that you learn is VR isn't a unifying concept, you know, so we lump together, you know, an immersive headset, a headset that was, or a system that was developed explicitly for rehab, or as you said, a non-custom system like a recreational game like the Wii, and they end up often being put in the same synthesis.
Right.
And that's a problem because VR isn't just one thing. So when we make a statement that VR does or doesn't work, you kind of have to dig in a little deeper and say, well, what VR works and what VR doesn't work. So that's I think one of the challenges with these synthesis documents. We did in the last one separate out what we call gamification from non-gamified applications, because that's a whole other thing, right? Some things are just simulations and other things are in fact gamified. Right. So they're good documents. I'm not knocking them. They're just like anything else. They can only go so far. And then I think maybe that's why so many other people do systematic reviews on the same topic. There's a million systematic reviews on this topic, Skip.
Right. Well,
does that make sense what I said?
You know, it makes total sense. You know, it's the hard, cold evidence, you know, that we have to rely on to, you know, make our case, whether, you know, where it works. You know, we're finding out, you know, 15 years later with the PTSD work that, you know, the traditional therapies work pretty good. Ours works at least as good, but there's other benefits. Like, you know, with PTSD, VR seems to work better with people with comorbid depression, you know, with PTSD. And that was a pre-planned prediction based on the idea that you could engage people in VR that were depressed as well, that would be very difficult to do in a traditional talk therapy context. And so, you know, I'm constantly juggling as to what is the evidence that you need. Is it just simply, you know, look, in physical occupational therapy, there's not a different theoretical model here to use VR. It's the model of promoting activity and exercise in a targeted way and so on and so forth. Is it, you know, so, you know, if you show non-inferiority, then is that good enough? And but with the added benefit that you may draw more people into doing it in VR or get them to more consistently do it. Maybe not with the robotic stuff, but maybe in-home use with a Quest, the cognitive stuff or whatever.
Yeah, I mean, that's a really common finding, right? That they're not that different from a well-constructed standard of care.
When it's delivered perfectly, when the standard
people
of care
enjoy it more. I think that's one important, that we consistently see this finding that people enjoy it more, or they report they're more motivated to do it. And so certainly that has a lot of implications for adherence and complying with activities that are generally not that exciting. So if they produce similar outcomes to well-designed therapies, but they're more enjoyable, I mean, that's the argument that people make. And that's what a lot of the data show. That being said, you know, there are probably other benefits, cognitive and perceptual benefits that don't always necessarily get tested. See, I think that we know that when people are interacting with these virtual environments, the cognitive operations are much more complex. And so in some studies we've done, literally they do the same number of repetitions, but it takes longer to do it in VR. Because you're processing what's going on and you're mapping yourself to the environment and you're trying to solve the problems in the environment. And so a lot of it really probably is residing with some kind of changes in cortical excitability and with neuroplasticity that we're probably not picking up. We've started using eye tracking now because they're built into the head-mounted displays. And so hopefully that'll help us a little bit with some mechanistic explanations for attention when we compare you know, interactions in environments. And we can track people in semi-immersive versus immersive environments too, and be able to say something about that. I think there's still a lot of questions to resolve, Skip.
Certainly.
People are very excited about immersive systems, but there's still a lot to be said about the semi-immersive ones.
Absolutely. Doesn't always have to be immersive.
No. And I think that we're a little bit fattest in this area, you know, the latest piece of technology, and we're all like, well, it's the best. Well, I don't know. It's the best for what?
Well, this brings up the point with the when you do hardcore explanatory randomized control trial, everything is like done to the precise letter of the law. The standard of care is delivered, exactly by the book, how it should be. A lot of times, that's not how standard of care goes in the real world.
Right.
And so this brings up the topic of, do we need to look more at, topic that's come up, and NIH has been promoting a bit, the pragmatic clinical trials, where you're actually testing in clinical settings, in real world settings, so that, you're actually seeing in the wild how some of these things operate, but you don't have that same level of
Control.
precise control. Yeah.
But I think that that's okay. I mean, I think that when we've done studies in the lab, we've called it optimal standard of care, because we don't have the distractions in the clinic, and we can deliver us, and it's a 2-on-1 like therapist to patient, which never happens in the clinic, right? So I agree with you. I think that pragmatic trials are the way to go. And Leanne Hassett in Australia led the Amount trial, where they incorporated both non-custom and custom video games into clinical practice to improve mobility for people who had mobility deficits. So they didn't even restrict the health condition, and has very, very profound and convincing results about their benefits in situ, in a real world context. So it's like 300 people in the trial, right? So I think there's some good examples of the technologies being tested that way, and hopefully more to come, come down the line. It's just a different way of thinking, right?
Yeah, right. You've also brought up the point about the things that we're not measuring in some of these trials that you think may be active ingredients. And a paper came out last week. I don't know if you saw it. It came out in JAMA Network Open about people getting total knee replacements. It made me think. I thought about this when we were talking about the worker's ankle, and they showed. And this is like one of these tangential findings, but has great impact. And what it is they find that when people do PT, not VR or anything, they do PT within 30 days and have more than 6 trials, that you see a large significant reduction in long-term opioid use.
Oh yeah. So they're showing that across a lot of populations. They're showing that with the low back pain.
And so if you can bring a way that seduces people to do this kind of therapy, you may have a larger impact, and maybe VR is a route for that. But I mean, these are the kinds of correlated societal knock-on effects that I think are worth studying when we look at the impact of any medical new technology approach or whatever.
Yeah, I also think that, when it comes to assessment, what we're really interested in is how people function in the real world. And we do all these tests in the clinic that are supposed to, predict or help us understand how people will do in the real world. And we could develop a suite of real world environments that allowed us to test things together: cognition, communication, sensory motor performance. So because all of those things get unbundled by specialties, and you go somewhere and this person measures this and this person measures that, if we could couple all of that, and I think that would be awesome. And that would sort of allow us to have a battery of tests that could help us understand how people will do in the real world, which is ultimately what we want to know, right? So that's kind of like that's a little bit more of my like, oh, wouldn't it be fun too kind of thing. Like, I think if we could do something like that, we could also move the field forward. And I feel like there's some worlds that are being built that could work for that. Like somebody's working on some aspects, but somehow there's got to be a way, Skip, to bring all these people together across the psych and the cognitive world and the sensory motor world. And, we all get a little bit specialized, but when you put the person back together and you understand what they are like in the real world, you can't do it with these little bits.
No, I mean, come on, post-stroke rehab it's not just about the exercise.
Oh,
It's
gosh,
about
no.
helping a person adjust to a completely different life experience. So to neglect the psychology of it and how they think about themselves. I mean, yeah, I mean, essentially rehab, you're trying to get people to do the things they're really bad at, and get them to
Well,
work out.
or things they want to do again, right? What's
Yes,
important, what motivates them to want to get back to
right.
what they're doing, and what's important and salient for them, right? So, and we never just work on one thing, right? We know in the real world of therapies that, we do a lot of overlapping things, even if though we're not specially trained for that. But when it comes to the science of it, we split everything up.
Hmm. Hmm.
I think that's a problem.
Yeah, absolutely. Absolutely.
Yeah.
So, on a more lighter topic, what gets you excited? What gets you out of bed in the morning to go into the lab? You working on something now that got you tickled, or what's your
Well, lately we've been interested in learning a little bit more about how to help persons who have Parkinson's be able to maintain their mobility and fitness. So we're still using a bike model, and we've interfaced some simulations with the bike, and we're actually still, one of our questions is immersive versus semi-immersive. Does it matter?
hmm hmm
And we're also comparing VR to no VR, because
hmm
if you give really good feedback in no VR, can you get a similar response? And then what does it matter? So those very, very basic questions. But then we're also playing around with competition, self-competition versus competing with others.
Right.
So what allows you to get the greatest? So speed of movement is an issue for persons with Parkinson's. And then we're also interested in a certain cardiovascular intensity for the fitness benefits. So can those manipulations actually separate out people? What would be the ideal training environment if you wanted to really get a good workout if you had Parkinson's?
So, in that context, would it be like, say, a family member, care provider, caregiver, in-home person that they participate along with the client in the activity?
Yeah, so in the literature on Parkinson's, there's been some work on tandem cycling, where people actually are cycling on a tandem bike, and the person who doesn't have Parkinson is the one that's helping you go faster. But that whole idea of a social interaction with someone that you care about, that would be maybe a more cooperative way of biking rather
Hmm.
than competing with them.
Right.
And I know that some of that work is being done in Denmark, to sort of look at and with older adults as opposed to people with Parkinson, doesn't matter. But that idea that you could, again, probably have a library of things you could do on a bike that could be shared by everybody, because probably they got tested by 2 different groups or 3 different groups, and we could put them together, kind of thing. That's something that we're working on right now.
Hmm.
Again, sort of in the guise of, can we do something that's already exists in a lot of therapeutic environments, or even in people's homes, a bicycle, and can we couple that with a virtual environment in order for them to have certain benefits for their fitness
I
and
think
their wellness.
I think this the collaborative game concept is really useful. Back when Belinda Lang was working with us, she's in Australia now, but
Great.
we had done a like an etch-a-sketch cooperative play
Yes.
activity for designed for kids with autism, where
Yep.
essentially one kid, by going up and down, would control the vertical of a rocket ship going through asteroids, whereas the other kid would shift their weight, and a Connect
Yep.
tracked them. And this is when we finally could track multiple users with
Right.
the Connect really well. And it was a cool game, but we never, it never escaped the lab. But it was a cool thing to see kids that wouldn't normally interact together now having to guide this rocket ship through an asteroid field. And I think that, I think the social support that would come from that for in-home stuff, I think would be good on a psychological level.
Yeah, and interactivity with other persons in your family, right? You could play the game with your sibling or with a friend or with a parent or whoever's around if you're a kid, or
Mm-hmm.
with some, a caretaker if you're an adult.
Hmm.
Yeah, I think there's some nice opportunities for stuff like that. So we're exploring some of that right now.
Do you think the the added interface is going to be a barrier to adoption. Having to have a bicycle, like you said, you use your own bicycle on this device, but like the stuff that Alma was doing with the haptic master and all that, and the more robotics you get, of course, you're getting force feedback, you're getting guided movement, but there's a cost. And
I think we've moved away from that. We've tried to really optimize and not have, that was what was so appealing about some of the things we did with the Connect. And so that's another alternative, right? I think there's different avenues that could be sought. And with Bike Skip, you don't even need a full bicycle. You can just have a little ergometer that you put on the floor and you pedal. So you don't even have to have a whole big bike. You could just, be sitting. And so I think there's some, I feel like there's some portability with the bike thing, which is why we keep trying to figure it out.
Right.
But I don't know. We'll see.
Yeah. So tell me, if you had it to do over again, would you still get mixed up with VR, or have you ever thought about leaving the field? If you got frustrated, or, couldn't get the funding, or experiment didn't go the way you'd hoped, or?
No, I have no regrets, for sure. No regrets. So for me personally, my interest is eventually to do something with global healthcare. So you might see me working for the Pan American Health Organization. I'll go back to Latin America, because I'm from Mexico. So go back to Latin America, So and it's not because I'm going to be tired of VR. It's just because maybe it'll be fun to do something on a larger scale, or maybe we will get it together and we'll build like one real cool project that interfaces with industry, and we'll be able to really leave like a substantial something for people. So lots of paths. But yeah, no regrets. It's just been, from knowing nothing to what we know now, it's been very, very satisfying. And we still have a few things, I think, to untangle that are worth clarifying. Even just simple things like the terminology we use, like what is VR, I think could benefit from some untangling. And I haven't given up on this open rehab being actually workable. This somehow democratizing and giving the technology, having more access to the technology. So it's not such a first world kind of proposition. Some kind of socially responsible business model that would really appeal to me. So still a few ideas percolating around, and definitely no regrets. No, it's been a lot of fun.
Yeah. Would you, is there a certain kind of person that is attracted to VR that makes it a career? Is there an element to it? We know hundreds of people that have been in the field for a long time, and even during the hard times, they stick with it. It's like,
so, I grew up in Mexico. I really like magic realism. So for me, like the whole thing about creating worlds and, it fits very well with my imagery work. Something about that stuff personally resonates with me. But I think beyond that, I personally really thrive in an interprofessional environment. I love working with people who have very different skill sets, and I love being able to integrate across that. So I think that's very stimulating. And it's never dull, right? Because the technology is always changing and the research is trying to keep up. And sometimes the research is ahead of the technology. So it's, who gets attracted to it? I think different kinds of people, because there's so many different requirements for who could do the work, and how to do the work. And probably the happiest people are the people that work with good teams, or have had great collaborations and, thrive on learning from each other. That would be probably for anything, but I think that would be the case. That's what I would guess for VR. Does that make any sense?
No, it makes total sense. You have to be collaborative by nature and open to working with people that know things you don't know. I remember my first design meeting for my very first VR app. I walked out of there like freaked, because, and I talked to a friend right after. I go, I'm not the smartest person in the room here.
Oh yeah.
But thank God there's smart people that are interested in what I'm interested in here, that want to work together. And that's the whole thing. You can't do it all. you have to have this cross interdisciplinary
Yeah.
collaboration. You got to do your best to understand their language and what their needs are when
Yeah.
you build this stuff.
And I wouldn't say that you're not the smartest person in the room. You're just smart in the stuff you know, right? As opposed to being, I don't have some kind of, I've done some coding, but yeah, I'm not going to write the code for this. That would be really inefficient, right? So, I just think there's got to be, like you said, understanding the vocabulary. Everybody speaks a slightly different language, so there's a little bit of translation going on there. I'm good with that. And then just being able to respect each other's skill set and being able to thrive by working together. Yeah, that's good science. That's really fun. That's why I stay around. Yeah. Okay, and then I get to go to fun meetings and meet people like you. And
well, that's always a good thing.
That's really fun too.
Next year, the ICDVRAT conference, International Conference on Disability and VR, et cetera, is going to be in the Azores in September.
Yeah, I saw the promotion for it.
Yeah.
Yeah, I did see the promotion for it. Okay, we'll have to see about sending some data there. Yeah. But I don't know if you remember, Skip, you and I were invited to speak in New Zealand.
Remember
together
that?
one year. And that was awesome. Because, I got to know you a little better too. It was really fun. I used to be a little scared of you, Skip, but then when I got to know you better in that meeting, I was like, oh, he's so nice. Why were you scared of him, Judy?
Oh yeah, that was good. It was a deep week of VR, it was really cool people too.
It was such a fun meeting.
And good beer. Last question before we take questions from our viewers here. Sure. This is my standard. I ask everybody the same question at the end. If you had 2 years, unlimited resources to create a VR application, what would you dive into?
Well, I think it's what I said a little bit earlier. I would love to have an interdisciplinary team put together a series of environments where we could assess for persons post-stroke, cognition, communication, and the ability to do the kinds of activities in order for them to participate in their roles in society. So being able to go and have a coffee with a friend, go to the supermarket, go to the bank, that would be, and then maybe have it be, translated, not just have it be in English, but have it be done in a way that we could use AI to just have it get ported over into, Spanish. Such a big part of the world speaks Spanish. That would be fun.
Yeah.
Do you have any connections? And obviously with an industry partner, Skip, it would have to be with the intent that it would be scaled and shared. Like otherwise, I think, you couldn't get all those good people together.
That's the tragedy of a lot of startups in clinical VR areas, is that they have a great idea and they bust their butt to get things together and get the money, and they build it, and then a year later they're running out of dough and they can't sustain it. And that's why I think that some of these larger companies that now are taking a serious look at VR are going to be what really carries in the future. I think there'll always be the place for individual developers to partner and feed into a larger platform, but sustaining this, it takes the resources and a vision for, I'm going to lose money for the first couple of years, 4 to 5 years, but when it finally all comes together and we have everything iterated and honed,
but if you had a mechanism where you could, because not everything is going to be commercialized, right? So you could have this pipeline of development and you could have one output be commercialization, but the other output be sharing.
Yes.
Wouldn't that be ideal? Because it's, in a way, it's not wasted work, and it gets translated into practice. So, with all the money that you're giving me, I'd like to build that out as well as a partnership with. Thank you for that generous offer.
Yeah.
But by the way, no way could I do that alone, right? We have to have a ton of really good people in the room.
Yeah, this is a conversation for after the podcast. There might be opportunities there.
That's good.
Okay, well, Jessica, do we have 10 minutes left, or 8 minutes? Do we have any questions from the audience, or do you have any questions?
Yes, so we have a quick question from one of the audience about, so for us discussion for you talked about how like applying VR technology in rehab, and you talked about how like there's like you had like clinical experience using like this type of applications in clinical settings. So some of our audience are wondering how has this technology been is all the clinics have the resources to get this type of technology, or is it still pretty early on, like they're just trying things out at the clinics?
Yeah, so we did a survey with Danielle Levac. There was a survey done in Canada and one in the US when we asked people what they're using of these technologies. And by far, the largest things were things like the Wii and the Connect, because people can afford them. And so there were a few people that were using more specialized systems. So for sure, there's still a barrier for cost and for understanding the value of the technology. And I think, for me, I think, Skip, I don't know what you think, it's confusing because companies do come up and do try to sell stuff, right? And then those companies don't last. Right. So there isn't the same kind of reliability. I remember Walter Greenleaf told me this once when we were starting to do our SBIR and trying to understand the whole business stuff. He said, distribution network, Judy, just remember, and he's so wise. And it's like, there isn't even a pathway for this stuff to get out and to be trusted. So I think large rehab centers get approached first, and they might invest in, and I know that that's the case. I'm in New Jersey. Kessler, I know, just recently made a purchase of 4 of one kind of system because they think that might have some value for them. So, but they have deep pockets. Right. So I'm not sure, how easy it is to use. I can tell you that when things like the Wii came out and I would go to the clinic and I'd watch people use it, the therapists were talking to each other and the patients were playing. So I couldn't quite understand what the therapeutic application was. So we really always felt we needed to teach people how to even use those. And we developed some resources to help you understand how to use them therapeutically. So it's a lot of stuff that isn't part of our education. That then, like, now you're in the clinic and now you're expected to learn it. So there's other things that need to be thought about, I think, for clinical adoption that starts with the training of the clinician.
Clinical training, absolutely. I mean, we have this issue with BraveMind. We don't just give that out to anybody that asks for it. They have to be able to document. They have, training and certification in traditional exposure therapy. But then, they have to participate in a 1.5 day intensive training with the system to understand how to operate it and how to implement it and so on. And we've been fairly fortunate with that. We've gotten some foundation funding that supports that, to be able to fly into a town and have people fly in and spend a 1.5 day hardcore. But if you don't get clinicians feeling comfortable with the technology, it's going to become a doorstop, and yeah, I know that I mentioned to you at one point about this company Penumbra. They're moving into this direction as well, and recognizing clinical training. But they also work with this foundation that is seeding VAs that have needs for physical occupational therapy, spinal cord, TBI, stroke, and all that, and getting some good adoption from that. But it takes sort of, when you have a corporate heavy come in and try to sell you something, automatically it's like, whoa. But when you are affiliated with, a foundation or different groups, sometimes that eases the acceptance that it's not just a product trying to be sold, but it's a healthcare tool.
Yeah, Skip, when we go to our meetings, like in the exhibit hall, like you'll see something, it'll seem interesting, and then it's not there the next year.
Right.
Or sometimes, they start coming back. So it just takes a while for people to get used to seeing that that's an option, that they want to even consider it. So I don't know.
There's going to be a help desk next year when you call. You're having a problem, Yeah, I mean, these are the pragmatics. I mean, we have our
For
head
sure.
down, focused on the science and documenting efficacy and effectiveness and everything, but the pragmatics of getting this stuff out the door is, I think, where the challenges are. But I think it's getting, I personally think it's getting better from what I see in the tech advancements and the lower cost, and now the will and interest by large entities, healthcare
Right.
networks, and so on.
I
So
think what's also better is much earlier inclusion of the end user and understanding both the clinician and the patient as the end user. And that'll help us develop stuff that people really understand and use. I think in the beginning, I said something about, it was really important to me that what we built was consistent with the way we make clinical decisions. So it should integrate with the kinds of things a clinician wants to be able to do, right? So that it's more organic with their practice. So I think that's really important at the front end from a design perspective.
Right.
That will then help, get it in the clinic and, all of that. So I think involving people in developing it is going to make it easier for adoption.
Yep, definitely agree. Okay, I think, Judy, I think you're off the hook now.
Yeah.
We could talk for another 3 hours, I think. I got through 1/3 of my questions, not even. But maybe we'll have you back another time. And I just want to thank you for taking the time out and being a good friend.
It was my pleasure, Skip. Thanks for the invite. Nice to hang out with you. And thank you, Jessica.
All right.
Thank you. Thank you so much for coming. And I know, like, I've heard all your conversation. I'm like really interested in this topic because I'm also working at a lab at USC at the occupational therapy lab in rehab for stroke. And we're also like developing a program on it used to use like VR, but now we're changing it back to a tele system, because like using a computer, because VR has been like not as accessible to patients during COVID, like it's harder for them to come into the clinics. So now we're like making it like a portable laptop. They can download the software on their laptop to like start doing the rehab at home. So I also think like the pandemic has been playing a huge part in the accessibility of this product and how this technology to the patients. If they can't come into the clinic, they can't really use it because we can't equip every patient with a VR headset with the system. So yeah, thank you so much. I learned so much from this talk, and I hope all of our audience have learned a lot, like as much as I did from our amazing speaker today. And yeah, thank you, Professor Judy, and thank you again to our host, Dr. Rizzo. I believe we have all learned so much on this topic. So for our audience, the video recordings of this event will be available on YouTube on our channel at Cognitive Leap Solutions, Inc. So please feel free to share with anyone who might be interested in this topic. So we look forward to seeing you again at our next event. So hope you have a wonderful rest of your day. Thank you.
See you.